Delta U is the change in internal energy. Q is the heat energy or heat transfer. So positive when thermal energy enters the system and negative when thermal energy leaves the system. W is the work done on the system. So it's positive when the work is done on the system, that means compression. It's negative when work is done by the system. The temperature remains the same during phase transition from solid to liquid state, therefore there is no change in kinetic energy. However, the potential energy increases as bonds are broken during the phase transition. Therefore, delta U increases. Like gases, work done by an external force W is positive when the solid contracts. This is because the direction of the force and direction of displacement is the same during compression. So for the same reason, W is negative when the solid expands. Since W is negative when the solid expands, Q must be positive in order for delta U to be positive. When the solid contracts, Q must be positive if W does not provide sufficient energy for delta U. However, Q can be 0 or negative if W is equal or larger than delta U. For example, ice can melt when a very high pressure is applied on the ice. The kinetic energies of molecules depend on the temperature. Therefore, there is no change in kinetic energy of the molecules when ice at 0 degrees Celsius changes to water at 0 degrees Celsius. The number of microscopic particles is proportional to the mass of a substance. For a fixed mass of 1 kg, the number of microscopic particles is fixed. In this case, the average potential and kinetic energies of these particles determines the internal energy of the substance. As given in the table, the potential energy of all the molecules in 1 kg of ice and water at 0 degrees Celsius is 0 joules and 3.36 times 10 to the power 5 joules respectively. Latent heat of fusion is the amount of energy required to increase the potential energy such that ice can become water. Hence, the specific latent heat of fusion of ice L is 3.36 times 10 to the power 5 joules per kg. This is consistent with the change in internal energy for 1 kg of ice. Work done by 1 kg of water, W is given by P delta V, and it is 1.69 times 10 to the power 5 joules. By the first law of thermodynamics, delta U equal to Q plus W, so the specific latent heat will be 2.26 times 10 to the power 6 joules per kg. There is little change in volume when the ice changes to water, but a large change in volume when water changes to steam. Thus, there is substantial work done, given by P delta V, when water changes to steam, meaning more heat input is needed for the work done required for expansion. The specific latent heat of vaporization of an object is therefore higher than the specific latent heat of fusion.